Alright guys, welcome back to a new video. So in today's video, I'm going to give you guys an introduction to NLP or natural language processing by showing you guys how to create a sentiment analysis predictor using logistic regression. So I'm going to take you guys through what NLP is, what are some of the use cases, and how we're going to go about creating our simple binary sentiment analysis predictor using natural language processing. So first of all, what is sentiment analysis? Well, sentiment analysis is the ability to analyze or predict the sentiment or emotion from a text. This is just going to be a binary sentiment analysis predictor, so we're either going to predict if the text has a positive sentiment or a negative sentiment. This can be a great video, so let's jump right into it. So, what is NLP? Well, natural language processing is exactly what it says. It's just the processing of language. So, anything to do with interpreting language, manipulating language, etc. There are many different use cases for natural language processing, such as text generation, sentiment analysis, classification, and many more. One big component of natural language processing is LLMs, or large language models, which are huge language models that are used to solve a variety of natural language processing tasks. Today, we're going to be working with sentiment analysis. Let's get started. So, I went ahead and created this model for a simple supervised learning task. So we're going to need features and labels to start off, and this is just the data that we passed into our model. So for our example in sentiment analysis, we're going to get tweets from Twitter. We're just going to make up tweets, right? And we're going to set them to either 0 or 1. So whether we think that it's 0, a negative sentiment, or 1, a positive sentiment. And this will be done on a larger scale when we're actually creating a model. We won't be using this exact model because this is a really simple architecture. And this is just one way to do this, just to get started with NLP. But we're going to talk about different ways to go about solving a sentiment analysis problem with more advanced and state of the art techniques, right? So, with our features, which is our tweets, we're going to pass these into our prediction function. And today we're going to be using the sigmoid activation function because the sigmoid activation function is good with simple binary tasks. So, this output is going to basically take the dot product of our features and our weights in our model, right? And it's going to get a value. So, if it's greater than 0.5, we're going to say it's positive. If it's less than 0.5, we're going to say it's negative. And we're going to take this value, so let's say 0.3. We're going to compare it to the actual value, which is our label, either 0 or 1. And we're going to be computing a loss on it, so a cost function. And we're going to be getting the cost or loss, right? They're the same thing. So we're going to be using the binary cross entropy loss function, which is, as it said, good for binary tasks. We're going to be getting this loss function, which tells us how much off are we from the correct answer. And we're going to be passing it back into our model. So we're going to be changing these weights a little bit. So the next time we train our model or we pass information into our model, it'll give us a better prediction, right? And we're going to keep doing this for as many epochs as we want until our model has reached desirable accuracy. All right, so this is just a really simple overview of any supervised learning model. So really in this scenario, the most important part is getting our features. And actually, that is the most important part with any model, right? So once we get our features, once we have the ability to convert this text into numbers or a vector that has some semantic meaning that we can use in our model and it'll give us good accuracy, the rest is simple. So we'll just get these features, we'll pass them into our model. So we'll do dot product with another vector of weights. That dot product will be passed into our activation function, the sigmoid activation function. The output of the sigmoid activation function is going to be passed into a loss function, the binary cross entropy loss function. And the output of the binary cross entropy loss function is going to be passed into an optimizer function, which is going to then optimize the original weights, the vector of weights, right? So we're going to continue this until our model's weights have allow us to have very good accuracy, right? So how are we going to convert this tweet into a numerical representation? So here are going to be two vocab words that we're going to be using for the rest of the book, right? So the first is our vocabulary. So what this means is every single unique word in our entire corpus or text. So out of all of our tweets, let's say we have 10,000 tweets, what is every single unique word in all of these tweets? So in the 10,000 tweets, let's say there might be 10 words per tweet, right? So in those 100,000 words, how many are unique, right? So we could end up with a corpus, I don't know, let's just say 10,000, right? So 1/10, probably not even accurate, I don't know. But let's say 10,000 words, and those 10,000 words are going to be our vocab, right? Our second word is one hot encoding. So this is going to be the basic way to encode any text. And here we take our vocab, which let's say is a list of every single word in our vocab. So, for example, let's say our sample vocabulary of 10 words might be I am, have, a cat, dog, I don't know, right? So, whatever those words are, we're then going to put an index for each one. So 0 could be I, 1 could be am, cat could be 2, etc. And then wherever in this new sentence we have I have a cat, we're going to fill those out. So 0 is that word, our vocab is I. Is it in this corpus? Well, actually, in this case, it is. So we're going to put a 1. Is am, which is our second word, is that in this corpus? No. So we're going to put 0. And we're going to keep going on for every single word in our vocabulary doing that, right? So then we'll have this really big vector. It's a sparse vector because it has many, many zeros. And it doesn't contain any actual semantic information about the text. It just tells us, is that word there? Is it not? It's good. We can use it. But we're going to have a lot of issues going on, right? Because this doesn't have any information about the text, right? It doesn't give us any semantic meaning really, and it's huge. It's the size of our entire vocabulary, and this won't help us when predicting. So let's talk about another method that we can use using frequency dictionaries. All right. Now let's see how we can use frequency dictionaries to create better encodings for our model. Let's say that this is our corpus, just 4 different tweets. We want to first categorize them into positive and negative tweets. So our positive tweets will be I love cats and I'm kind, and our negative tweets will be I hate math and I'm mean. Now, using this information, we can create a positive and a negative frequency dictionary. So these dictionaries are just going to be the size of our vocab, including all of the words in our vocab as keys, right? So we're going to have I love cats, hate math, am kind, mean, which is our entire vocabulary. And the same thing here. So for a positive frequency dictionary, we want to go into our positive corpus and we want to basically tally how many times each of the words appear in that respective corpus, right? So let's say positive, I appears twice, love appears once, appears once, etc. Our negative, I also appears twice, love appears 0 times, but hate appears once and math appears once, etc., right? So, what this will allow us to do is basically kind of get an understanding of what words have a positive or negative sentiment, right? So, in both the positive and negative frequency dictionaries, I comes twice, which basically tells us that it's a neutral word. Hate only occurs in the negative dictionary, which can tell us it's a negative word, right? It's just a simple way to get some sentiment out of our text, right? Which we didn't get in a one hot encoding. Let's see how we can use these dictionaries to actually create our encoding. So let's take the text. Let's try to create a new text. Let's just say, I hate cats, right? So this new text, which is I hate cats, which isn't in our corpus already. So we're going to first see how many times does this entire sentence. So we're going to add up all of the tallies in the positive dictionary, right? So I appears twice. So we're going to say 2. Hate appears 0 times. So that's 0. And cats appears 1 time. So the total positive number is 3 because I is 2, hate is 0, cats is 1. So 2 plus 1 is 3, right? Our negative dictionary, I appears twice. That's 2. Hate appears once. That's 3. And cats doesn't appear. So that's also 3. So in this scenario, our model is going to create an encoding, which is 1, which is just a bias. We can just set that as 1 for now. And our positive, which is 3, and our negative, which is 3. Right. So this is just going to be the encoding that we're going to pass our model. 1, 3, 3. And this specific encoding is for the text, I hate cats. Now, this is without pre-processing. I'll talk about that in another video. So you can see this is kind of telling us that this text is neutral, which it really isn't, but our model is um, has so little data. It's only 4 different tweets, which isn't going to be accurate, right? With many, many tweets, this will start to make some sense. Let's try using one from the corpus, I love cats. So how we're going to do that is going to be 1, and then now let's find our positive, which is I, 2, love is 1, cats is 3, that's 4. And then I love cats here, that's 2, 0, 0. So that's just 2. So this is going to be 1, 4, 2, which is great. This is going to tell our model that this is kind of like a positive sentiment tweet.